Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at more units of concentration. We are starting by looking at molality. Don't be confused with molarity. They are two different things. Your symbol for molarity, if you remember, is a capital M. The symbol for molality will be a lowercase m or a little m, as I like to say. Um, Remember, molarity is the ratio of moles of solute to liters of solution. Remember, solute is what's being dissolved, um, and the molality is the ratio of kilograms to solvent. Remember, solvent is kind of another way to say solution. It's what's doing the dissolving. Um, So remember, solute is what's being dissolved. Solvent is what's doing the dissolving or what is being dissolved in. Our formula for molality is moles of solute over kilograms of solvent. So again, just like if we put it into symbols, it's moles per kilograms. And remember, that will equal little m. So first question, we have a solution with 1.34 moles of sodium nitrate and 2.5 kilograms of water. We are putting the sodium nitrate in the water and dissolving. So it's asking us to calculate the molality. Remember, molality is little m. The formula is moles per kilograms. So that's what you see here. I just substituted in the moles that I have here, and then I substituted in the kilograms that they gave me in the bottom. Um, Make sure you solve. Type it into your calculator. That's all you have to do. Question two. Question two, now we're thinking back to question one. Do you have enough data up here to calculate molarity? Remember, molarity is moles per liters, molality is moles per kilograms. Do you have all the information you need to answer this? Question three. Question three is asking us for the molality of a solution that is made by dissolving 32.6 grams of sodium sulfate in 475 grams of water. So remember, guys, molality is moles per kilograms. So we have grams and we know the compound, so we can calculate moles. That's what you see me do here. So I took the grams, I set up a T. I filled in my value. Remember, this mass, this is the mass from the periodic table. It's the mass of 2 sodiums plus 1 sulfur plus 4 oxygens. That gives us the moles, 0.23 moles of sodium sulfate. Remember, guys, whenever you go from grams to kilograms, we do that by dividing by 1,000. So we have our 475 grams of water. So you divide by 1,000. Remember, guys, dividing by 1,000 is the same thing as moving the decimal place over 3 times. So that's how we get 0.475 kilograms. The last step, guys, would be to plug in your values into the formula. So you plug your moles in there, and then you would plug your kilograms in there, and then solve. Question 4. So question 4 and 5, they ask you to calculate molarity and molality. So you can calculate molarity the same way you did on the previous ChemQuest and the previous practice. You calculate molality the way I showed you in number 3. Convert your grams of solute to moles if they don't already give it to you. Question 4 they do. Question 5 they don't. And then convert your grams to kilograms. But in both problems, you already have kilograms, so you will not have to do that. So next, we are moving on to some information on mole fraction. So a mole fraction is just another way of expressing the ratio of moles of solute to moles of solvent. So remember, guys, your solute is what's being dissolved. Your solvent is what's doing the dissolving. So these formulas are important. I only highlighted part of them this time. I highlighted part of them to show you that whatever you're solving for is on the top. So in the first one, we're solving for solute, so moles of solute is on the top. The second one, we're solving for the mole fraction of solvent, so our moles of the solvent is on the top. The bottom stays the same. It's the total number of moles in the entire solution. So that doesn't change. Remember, what I highlighted does change. So question 6. Question 6, we need to prove that the mole fraction will equal 0.049 when we solve here. So the first thing, they gave us grams. Remember, guys, Grams, the mole fraction is in moles, not grams. So the first thing to do is to take our grams and convert to moles. So that's what I do right here. So I take my 14.25, I'm dividing by 58.44. Remember guys, this is the mass from the periodic table by adding 1 sodium plus 1 chlorine. When you solve for that, it comes out to 0.244 moles of NaCl. So then next, we are converting our grams of water to moles of water. So we do it the same way. We take our mass of water from the periodic table. This is the mass of 2 hydrogens and 1 oxygen. That comes out to 4.718. Sorry, moles of H2O. Now the last step will be to plug our values into one of the mole fractions. So what you need to ask yourself, it's asking us about NaCl. Remember, NaCl in this case, NaCl is the solute. It's the solute because it's what's being dissolved. We are dissolving the salt in the water. So we would use this one. So then we know that we have our X that will equal the moles of the solute, which is NaCl, 0.244, over the total number of moles, the moles of the solute plus the moles of the solvent. So 0.244 plus 4.718. That does say 4.718. It got a little smushed. After you type it into your calculator, you do find that the mole fraction equals 0.49. So question 7, guys, you need to find the mole fraction of water now. You can use the same number of moles. Just remember, what's going on top changes. It's no longer the moles of sodium chloride, it's the moles of water. So repeat this step using the moles that we already calculated. Question 8. Question 8, we're trying to prove that the mole fractions of any solution will add up to 1. So we can prove that by using these values up here that we find. So we know that this is the mole fraction of salt, sodium chloride, and then you just calculate the mole fraction of water. So we can substitute. Our solute is salt, our solvent is water, and when added together, they must equal 1. Question 9. Question 9, you know that the mole fraction of salt is 0.18. So remember guys, salt will be your solute because it's what's being dissolved. So that will be able to be plugged in over here. And then the mole fraction of water you can solve for because we know that the mole fractions added together for any solution will equal 1. So you should just plug in your 0.18 and then solve for the solvent. Next, we have percent composition by mass. Very similar to the mole fractions, the only difference is instead of using moles, we're using masses instead. So it's a little bit easier. If you're given masses, you don't have to convert them first. So that's what happens in question 6. We look back at question 6, and we have 14.25 grams of sodium chloride, NaCl, and then you have 85 grams of H2O. So what I did was just write them down as I was saying that, so then we don't have to look back up there. So now we just need to plug our values in. Remember 14.36 will be our answer. So solute, remember guys, we said that the solute was sodium chloride, so that will go on top, 14.25. And then the bottom will be the mass of the solute and solution, so 85 plus 14.25. And then again, all of that is multiplied by 100. When you do solve, you see that it comes out to 14.357, which would round to 14.36%. In question 11, you are asked to calculate a percent composition by mass. However, it does not give you grams of water. Instead, it gives you milliliters. It does put a note down here. This is something that's important, something you will need to know, so highlight it, star it, whatever you have to do. You will have to know that 1 milliliter of water has a mass of 1 gram. So what we see here is that your milliliters equals your grams. So 250 milliliters of water will equal 250 grams of water. So then you can use your grams to calculate your percent composition by mass. That's it for this ChemQuest, guys. Remember, if you have any questions, circle them, write down your question, and then ask me in class. Hope everyone has a good day. Goodbye.